welcome back. So we wrapped up everything about lines, and now it's time to move into exponents. We gotta cover some basics about exponents. We gotta know how to apply all the rules and laws before we start working with functions. And that's because a lot of functions are going to include exponents. So it is very, very important that you master this chapter. I'm also going to provide a printout of all of these rules so you can download it, have it on your phone, have it on your laptop or iPad, or simply print it out and have it near you when you're doing your homework. So there's a few simple rules that you have to keep in mind, and the best way to remember them, if you do not have them nearby, is through practice. And that's exactly what we're going to do in this video. We're going to cover all of the rules and provide a few examples for each one so you can get acquainted and see how it works in action. Sounds good? All right, let's get it going. So we have product rule, quotient rule, power of a power rule, that's a mouthful, power of a product rule, power of a quotient rule, zero exponent rule, negative exponent rule, and fractional exponent rule. Okay, so I'm going to start with this one. I think a lot of people are confused about zero exponent rule because you have learned that anything multiplied by zero is zero, but we are not multiplying here. We are putting things into power. We are putting, a number, a variable into a power. So let's start with that. Keep in mind, anything and everything to the power of 0 is always equal 1. That includes a to the 0, x to the 0, 29 to the 0. It's always going to be 1. So whenever you see a power of 0 or an exponent equal to 0, immediately think that it's 1. Keep in mind, a to the 0 does not equal 0. Okay? Putting things to power and using exponents is not the same as multiplication. So that's the number one rule I want you to remember. Okay, now let's get back to the beginning and start working with the product rule. So the product rule goes as follows. If we have the same base, right? So base is the number or the variable that we actually raise to a certain power. So in this case, if we have the same base, a to the power of x times a to the power of y, or on the sheet it's m and n, those are more common ways of expressing exponents, but I just want to exemplify something different. You can basically summarize that it means a to the power of x plus y. Okay, so let's actually see how it works with certain numbers. Let's say we have x to the power of 2 times x to the power of 7. Since the base, right, in this case it's x, since the base is the same, then you can just add the exponents. And 2 plus 7 is 9. 2 plus 7, and that's equal to x to the power of 9. Keep in mind, the base has to be the same, right? If we have an example like x to the second times y to the third, we cannot use the product rule because the base is different, right? I don't even know what to write here because the bases are different. So let's just scratch that. I wanted to emphasize the point. Can I get the eraser? Thank you. Okay. So hopefully that's clear, and you're going to remember that base has to be the same. Let's do one more example. Let's do a to the power of 10 times a to the power of 5. Okay, so you are not going to multiply 10 times 5. You are always going to add, right? If there's a multiplication of the same basis. So it's a to the power of 15. Simple enough. Okay, let's move on to the quotient rule, a very useful one. So this one involves division of bases with different exponents. So let's consider a to the power of 7 divided by a to the power of 5. Then we can write it out as a to the power of 7 minus 5, or simply a to the second. Now, you might be asking yourself, why are all of these rules necessary? Can't you just put things to the power and calculate everything and deal with it at the end? And the answer is, you absolutely can, but you're going to waste a lot of time. Let me give you an example. Let's consider that we have 3 to the power of 9 divided by 3 to the power of 4. You probably do not know the answer of 3 to the power of 9. You probably do not know the answer, or you might, of 3 to the power of 4. And calculating those individually might take you a longer time than saying, hey, these are the same bases. Why don't I just apply the quotient rule and simply write 3 to the power of 9 minus 4, and that's to the power of 5. Now, calculating this one might be a hassle for some of you as well, but it is way, way easier than calculating 3 to the power of 9 divided by 3 to the power of 4. You not only have to put them to a power, at the end, you still have to perform division. So always apply rules and laws of exponents before providing an answer or performing the final calculation. Okay, next we have power of a power. So rule number 4 does not involve the same base, okay, but it's still very useful. So let's say we have x to the power of 3 to the power of 2. So in this case, x to the power of 3, it is its own variable. I think that's the best way to describe it. So you don't have to calculate x to the 3. Let's say x is 2. You don't have to calculate 2 to the 3 and then raise it to the second power again. You can simply say, oh, this is x to the power of 3 times 2, which is x to the power of 6. Let's do a numerical example so you can see how it works in action. So I said, okay, we have 2 to the power of 2, and then I want you to square it again. You know, you can keep calculating in your head. Numbers are simple enough. Or you can simply say, by applying this rule, that it's 2 to the power of 4. And what is 2 to the power of 4? It's simply 2 times 2 times 2 times 2, which is 16. You see how those rules can really simplify your life, and that's only if you remember them or if you have this sheet laying around or saved on your phone. But I highly recommend for all your quizzes, homework, and tests, and simply to save you time, to just memorize them. Okay, next we have a power of a product rule. Okay, that's a mouthful, but also a very useful rule. So in this case, we have two different bases, a and b, but they're raised to the same power, m. So you can simply write, okay, this is a to the power of m times b to the power of m. So you are basically applying the power to both bases. I think that's the best way to put it. Let's consider 3x times y squared. And that might be a little bit confusing to some of you because for the first time, in this case, we have both a number and a variable. So we have to square both. We actually have to square both. So it's going to be 9x squared times y squared. And that's your power of a quotient rule, power of a product rule in action. Now let's do a few examples for power of a quotient rule. So whenever you are dealing with fractions raised to a certain power, you can distribute the power to both the top and the bottom. So let's say we have a over b to the power of 6. You do not have to calculate what the fraction is if those variables become numbers. You can simply distribute the power to both the top and the bottom of the fraction. So it's a to the 6 divided by b to the 6. And using numbers or different variables first, let's do x divided by z squared to the third. So simply distribute the power. Now this one's a little bit more challenging because we have to apply another rule. So on the top we're going to have x to the third, and on the bottom we're going to have z squared to the third power. So what happens when we already have a power and we raise it to another power? We simply multiply the powers. So it's x to the third divided by z to the power of 6. And let's consider a numerical example. Let's say I want to do 3 over 4 squared. You can just say 9 over 16 because you applied second power to both the top and the bottom. All right. We already covered the zero exponent rule, so I'm not going to do any more examples on that specific law and that specific rule. But let's talk a little bit about the negative exponents. So rule number 7 is all about negative exponents. So a to the power of -1 is equal to 1 over a. Now a to the power of -2 is equal to 1 over a squared. So the negative power simply indicates a reciprocal. So all you want to do is flip the fraction around, and there you have it. And to exemplify something different, let's say we have a fraction 3x over 2 to the power of -1. That's going to be 2 over 3x. So every single time when you see a negative sign in your exponent, think in your mind about flipping the fraction. And also applying other exponent rules. Let me actually exemplify that in this case. Let's say we have 2x squared divided by 5 to the power of -2. Now, if you're comfortable with applying these rules, you can actually do it in one step, but I'm going to separate it, okay? So first, I'm going to apply the negative exponent. So I'm going to say it's 5 over 2x squared, okay? So I applied the negative exponent, and I flip the fraction. Now I can apply the power. So it's going to be 25 because 5 squared is 25. And on the bottom, we're going to have 4x to the 4th. right? Because a square of a square, we just multiply those numbers. 2 times 2 is 4. All right, rule number 8, the last one, fractional exponents. And I think for majority of students, this one is the most challenging one. Because there's a lot of different things going around. All of you have seen radicals before. All of you have seen, a square root, a third root, but now we're going to express the radicals in a way or in a form of a fractional exponent. So before we talk about it, let us do an example. So for example, in this case, right, a square root can be written as x to the power of 1/2. Let me actually emphasize a few things here. So in the square root, we don't write this 2 here, but it's always there. And most of the time, we do not use exponent of 1 because anything to the power of 1 is itself, basically. X to the power of 1 is just x. But things begin to change when we complicate it, right? When we start adding different numbers in the fraction. And what I mean by that is, for example, x to the power, and let me use colors again, I think it's going to help us a lot. So 3 over 5. So the number on the bottom of the fraction is always going to be a root. The number on the top of the fraction is going to be the power on the inside of the root. So that will be equal to x to the power of 3, and we're going to have a 5th root. Let's do one more example using a different base. So for example, a to the power of 2 over 7. Okay. Once again, your numerator is the power attached to the base. The bottom of the fraction, or denominator, is dictating what root you're going to use. So in this case, it's 7th root of a squared. Sounds good? All right. So I know that was a longer video than usual, but once again, you can simply have this printout laying around, or have it on your phone, or on your iPad, or whatever tablet you're using, or have it in your computer in a different window. And when you're going through homework problems, and you forgot a rule, you're uncertain about something, just take a peek, do an example, and this way you're going to learn the fastest.